So here it is, right triangles and trig. Let's see what this says. All right, guys. First, excuse my right triangle to the left. I'm using paint. Yeah, I didn't have to say that. I don't know why. When I typed it out, that's what I typed out. I'm using the Microsoft Paint editor, but there was no reason for me to say that, right? Like, all right, that's about as flashy as my triangles. Okay, whatever. Okay, let's start with basic geometry. Okay, so here we go. This is a triangle. This they call that a vertice. So vertice A, vertice C, vertice B, and you write the vertices with capital letters. And then this angle, we're going to call that angle A because it starts at vertice A. That angle, the opposite side, creates little a. So there it is. That's what you call opposite. So angle B, wherever this aims, pretend like this is bird's eye view and you're standing right here. If you're looking like that, that's going to be side B. And then here, this is my right angle there. So that right angle creates your hypotenuse, and that's side C. And then from there, you get something that's called Pythagorean theorem. And that's why the Pythagorean theorem is always a squared plus b squared is equal to c squared. Do you guys remember that? That's called Pythagorean theorem. Now, these are called trig ratios. So a ratio is just a fraction, something on top, something on bottom. So maybe Mr. Q or Mr. Quinones has told you to use this acronym called SOHCAHTOA. SOHCAHTOA. And it's just an acronym to help you. So how do you use it? That S stands for sine, the O stands for opposite, the H stands for hypotenuse. So sine is opposite over hypotenuse. The C stands for cosine, the A stands for adjacent, the H stands for hypotenuse. So cosine is adjacent over hypotenuse. The T stands for tangent, the O stands for opposite, the A stands for adjacent. So tangent is opposite over adjacent. And there it is. So, and I know when you see the letters SIN, you're like, why are you pronouncing it sine? That's sin. Okay. When you say this, you say it like if there's an E right there. So it's sine. If you were to say sin A, I wouldn't get mad. I'd be fine with it. But you know, like whenever you talk to your next professor, like you want to make sure they use the correct vocabulary, academic vocabulary. But it's pronounced sine. Does that make sense? So this COS is pronounced cosine, and that TAN, that tan, is pronounced tangent. Are we still okay? Okay. Now this is called an argument. Everything almost like so I should be putting parentheses sine A, tan A, cosine A, but I have a bad habit. That habit comes from Delta Math and from textbooks. Some textbooks do not put parentheses, but we should be putting parentheses. It's just like saying f of x. See, that just means it's a function with respect to x. You don't say, I mean, I guess you do say f of x, but look, like it looks weird without putting parentheses there. Now, when you get to calculus, especially multivariable, there is something called capital D with a subscript x on it. That means derivative with respect to x. Well, we're not there yet. You're not doing partial fractions yet. You're not doing any of that. You're not doing partial derivatives. Partial fractions has nothing to do with that. But anyways, yeah, we're not in calculus. We're just in pre-cal. So there it is, basic. Nothing crazy, right? Okay. So here we go. I'm going to use this acronym to help me out. So it says sine A. So according to this right here, I have this SOH. I'm using this one, sine. And it says it's opposite over hypotenuse. So I'm going to go to my angle A, and I'm going to say, okay, what is opposite? What letter? Lowercase a. And the hypotenuse is C. So I'm going to write A, lowercase a over lowercase c. Remember, guys, this lowercase c is always called the hypotenuse. And I guess I should have, before I jump to the cosine, let me talk really fast about what this A stands for. Remember that the A stands for adjacent. The letter A, A adjacent means next door. And Oyani, that's going to be demerit. You're good. So if someone gives you, do you guys have little brothers and little sisters? No. You have a little brother, little sister? You have a little brother? No, you have. I have. Okay, your little brother, little sister. So whenever you see your little brother, little sister, give them a cookie and go, take this cookie to the adjacent room. I don't know how to do it. You know, what do you think your little brother's gonna do? He's gonna take context clues and he's gonna be like adjacent, unless he knows the word adjacent. How old is your little brother? She's in sixth grade. Sixth grade. Do you think she knows the word adjacent? Okay. Well, hopefully they'll use their context clues and they'll be like adjacent. Ooh, I think that means next door. So it means next door. That's all it means. So I know maybe you're saying, could segment C be adjacent? Well, technicality, it is next door to angle A, but segment C already has a name. Segment C, what do we call that? So because it has a name, that's it. That takes priority. So the hypotenuse is segment C. So what else is adjacent to angle A? Yeah, what's the lowercase letter? B. So lowercase b is adjacent to angle A. Does that make sense? Okay, and I know I am going to say something, but I forgot what I was going to say. Oh yeah, that's what I was going to say. Guys, you don't have to just label. See how I labeled this segment lowercase a? You could have also called that segment BC like that. Why do they also call it BC like that? Well, because that segment connects B and C. Does that make sense? Sometimes you'll see it like that. Sometimes you'll see a little bar on the top. They're all the same. Sometimes with that little bar on the top, you give it a number, but all of it means the same thing. So hopefully we're helping your SAT, ACT, TSI scores right now. Do you feel your scores getting larger? Okay, I hope so. All right, so hopefully, there we go, guys. I guess I can leave it BC. All right, here we go. Cosine of angle A. So cosine is adjacent over hypotenuse. Here's my angle A. So what is adjacent to angle A? Little b over c, because that's my hypotenuse. All right, tangent of angle A. Tangent is what over what? Okay, what's opposite to angle A? Little a. What's adjacent to angle A? There you go. So little a over b. All right, cool or not cool? Let me open that. Come on, guys. All right. Here we go. Reciprocal function. Do you guys know these reciprocal functions? Have you guys? Did Quinones talk about them? Okay, relax. We're good. We're good. These are called reciprocal functions. Reciprocal trig functions. They actually can go both ways, but we'll talk about that in a little bit. The way you pronounce it, CSC, the way you pronounce it, you pronounce that as cosecant. SEC, the way you pronounce it, you pronounce that as secant. And COT, you pronounce that as cotangent. Do you know what the word reciprocal means? It's okay if you don't, guys. So if I tell you, don't worry, we got you. So if I tell you what's the reciprocal of 2/3? Perfect. 3 over 2. Use context clues. What did I do when I found the reciprocal of 2/3? Yeah, the numerator turned to the denominator, and the denominator turned to a numerator. That's it. That's all you're doing. In math, if you ever see a little button, and that button looks like this, that's called the reciprocal button. And that button is going to do that. Are we still okay? Okay. All right, here we go. Cosecant of A is the reciprocal of sine A. So because cosecant of A is the reciprocal of sine, I'm going to say what? C over A. Does everyone understand what we just did? Okay. Secant of A is the reciprocal of cosine of A. So I'm going to say what? There we go. Cotangent of A is the reciprocal of tangent of A. So what am I going to say? There you go. Guys, wait. You got it so ready. It is not extremely difficult to remember these. Let me give you our first hack. See how cosecant starts with a C? We're going to call these the originals. Cosecant is the reciprocal of the one that starts with an S from the original. Look at secant, it starts with an S. Remember that secant is the reciprocal of the one that starts with the C. By the way, you can also call these reciprocals. You can call these, sine is the reciprocal of cosecant. It works both ways, see? Cosine is the reciprocal of secant, because see, what that means is you take C over B and you flip it and look, and you get B over C. Tangent is the reciprocal of cotangent. See, the vocabulary goes both ways. You can say cosecant is the reciprocal of sine, or you can say sine is the reciprocal of cosecant. It works the same. Are we cool? Okay. How do we feel? Do we feel okay? Okay, now let's take a different color. I did all that with red. Now I'm going to take purple. You don't have to take purple. It could be a pen, or you don't even have to do your notes like this if you don't want to. I'm just changing colors to know that I have a different argument here. So here's my different argument. I am going to look at angle B specifically. So here's angle B. So there I am. I'm looking at angle B. So I put a little curvature there on angle B. If you want to put an angle like a theta or a Greek letter, that's fine as well. All right, so here we go. It says sine B. Sine is opposite over hypotenuse. What is opposite of angle B? Little b. And then hypotenuse is C. So there it is, B over C. Cosine B. What is adjacent to angle B? Little a over little c. Tangent B. What is opposite to angle B? B, and then my adjacent, A. Job, where did you get opposite and adjacent? I use my little acronym. The little TOA there, that helps me out. Tangent is opposite over adjacent. I'm going to go to the cosecant. Cosecant of angle B. Cosecant is the reciprocal of which one? Sine. So what am I going to write? C over B. Secant B. Secant is the reciprocal of? So what am I going to write? C over A. Cotangent is the reciprocal of tangent. So what am I going to write? There you go. Look at you guys being nerds. See? Like, now, like, was that hard? No. Was this doable? You can do it, guys. See? So hopefully all my explanations are clear, and let me know if something doesn't make sense. All right, so here we go. Now let's apply it. Now we got numbers. So it says sine A. I'm going to write my little SOHCAHTOA here. SOHCAHTOA. And it says sine A. So I'm going to exaggerate. I'm going to put the little angles there. So I'm going to go to A. So here's my angle A. And it says sine. So sine is going to be what over what? Perfect. The 13 is the hypotenuse. So I'm going to write 5 over 13. There it is. The hypotenuse is always the longest side, wherever this right angle aims at. So that's my hypotenuse. Okay, cosine angle A. I'll go to angle A. What's cosine? It's what over what? 12 over 13. Here's 12 over 13. And then finally, tangent of angle A, opposite over adjacent. So hook me up. What is it? 5 over 12. Look at you guys. Do you guys feel good? Yeah, look at you guys are nerds. You guys can do this. We can do this, miss. Okay, sorry. I get kind of hyped sometimes. Sine C. I'm going to change my colors. I'm going to go to burnt orange. I don't know if you guys are Longhorns, but if we have any Longhorns, I'm using the burnt orange here. Sine C. So I'm gonna exaggerate C here, angle C, and it says sine is opposite of our hypotenuse. So what am I going to write? 12 over 13. Cosine C. What am I going to write? 5 over 13. And then tangent to C. There you go. Good job, guys. How do we feel? Yeah. Let's go to the next one here, guys. This is a special right triangle. If you know it, this is a 9, 12, 15. Relax. I know, just like last period, they were like, no, they didn't get it. I can sometimes tell by looking at y'all's faces whether we got it stuff or not. You look angry, but we're not angry, right? Yeah. Sorry if I called you out there because you're like, we're good. Okay, no, we're good. If we don't know that, guys, YouTube, I promise I'm not picking on any of my kids. I'm just looking at their faces. All right, so here we go. If you don't know that, here's what we can do. You can always use Pythagorean theorem. That's my hypotenuse there. So if I didn't know that, I'm going to call that little y. So that's just a little y there. So I'm going to go 9 squared plus 12 squared equals little y squared. Because that big y created that little y there. 9 squared is 81. 12 squared is 144. And that still equals my little y squared. Are we still okay? Okay. 81 plus 144. Let's see. You guys know? Here's how I do it. I'm not the fastest. If you guys can think of a faster way. 144. I can add 144 and 100 really quick. So that's 244. But that's not 100. That's 81. So I got to subtract 19 from that. So let's see. 244, 19. So the 20, the 224, 225. 225. See? I'm not the fastest. So maybe some of you guys are faster than me. So there it is. And now I need to take the square root of that. So that's how you get the y by itself. Square root. So square root by definition means a number. Well, this is a perfect square root. 15 times 15 will get you 225. And as soon as you have a pair that repeats, that's what that square root means, right? By definition. So y equals 15. So there it is. So that's 15. Do you guys see how we did it? Okay. Are we happy? Is everything making sense? Okay. All right, sine W. I'm going to exaggerate the W there. I'm going to write SOHCAHTOA again. Don't worry, we're almost done. We're almost done. And I'm going to write sine. So it says sine W. So sine is opposite over hypotenuse. So what am I going to write? 12 over 15. Now 12 over 15, if you wanted simpler, if you want to reduce this in simplest form, that's what it's called, simplest form. 3 goes into 12 how many times? 4. And 3 goes into 15, 5. See? 3, 6, 9, 12. 3, 6, 9, 12, 15. So there it is, guys. So 4 over 5. Cosine W. So cosine W, so adjacent over hypotenuse, what's that going to be? 9 over 15. And 3 goes into 9. And 3 goes into 15, 5 times. All right, tan W, opposite over adjacent, what am I going to write? 12 over 9, and then 3 goes into 12, 3 goes into 9. There you go. How are we feeling, guys? Okay, I'm going to change my colors. I'm going to exaggerate it on the X. So here's my X. All right, here we go. Sine X. Sine is opposite over hypotenuse. What am I going to write? 9 over 15. Again, 3 goes into 9 how many times? So 3 over 5. Cosine X. What am I going to write? 12 over 15. 3 goes into 12 how many times? And then 15, 5 times. And then finally, tan X. So what am I going to write? And that reduces to? There you go. How are we feeling, guys? Okay. Let's go to the next one. Relax, relax. We're fine. We're almost done. We're halfway there, guys. I hope this is not torture. Is this torture? What would you rather be doing? This is awesome. I mean, would you rather be in dance class? I should not. Yeah, dance is probably a lot of fun. Let's do a little more, unless you can't hold it.
Sorry.
Okay, go. Watch my video. I'm recording this.
Okay, I already followed you.
Okay. In triangle ABC, the measure of angle C is 90 degrees, so put C right there. Don't close the door completely, that way you can come back in. Yeah. And then it says CB is 3, so it doesn't matter where you put the A and the B now. The A and the B vertices. So I'm going to say, it says CB3, so I'm going to put 3 right here. It says BA5, so I'm going to put 5 right here. And it says AC4, so I'm going to put 4 right there. So that's a 3, 4, 5 triangle. It is a special triangle, but it's not a big deal. Okay, and now it says, what is the value of cosine of angle B? All right, so I'm going to write SOHCAHTOA. Guys, if you're beast, you no longer have to write SOHCAHTOA if you already know what you're doing. I'm gonna double underline the CAH to help me out, and I'm gonna write cosine of what angle? Cosine of B equals, all right, so with respect to angle B, what is adjacent? 3. What is hypotenuse? There it is. Cosine of angle B is 3 over 5. How do we feel? Yep. Now, they're not asking for it, but I'm going to see if you guys know this real quick. If I wanted angle B by itself, like let's say I wanted to figure out what that angle was. So how do I get B by itself? So this is cosine of B. Remember, this is not cosine times B. It's cosine of B. So I can get that cosine out of there. Let's see if Quinones told you guys. It starts with letter I. I guess you can start with letter A also, but probably told you the letter I. Second letter N. No, not imaginary. N. Third letter V.
Inversion.
You're close. Not inversion, but inverse. You get the Quinones tell you about that or no? Or yeah? Okay, relax. It's okay, guys. If you wanted to get B by itself, you have to do the inverse cosine. So, Tom, what does that even mean, inverse? Remember when you were with Quinones, if you have a function, so, okay, don't write this down, put your pencils down, just listen, and then you can write whatever you want to write in a little bit. So if I tell you I have a function f of x, and I tell you that I found the inverse of that is f to the negative 1 of x. Does that look familiar to you? It's the same with trig. If I have cosine of x, and I want to know what the inverse of that is, let's say I say y equals cosine x. If I do the inverse of both things, and I go inverse cosine, and I have a y there, y equals x. So the inverse gets rid of your cosine, and then, see? So inverse cosine of y equals x. So that is tied to these two right here. Does that make sense? Yeah. Do you guys want to write that down or no? It's up to, okay. So I'll give you guys some time to write that down real quick. I'm really thirsty. I think it's because I've been talking. I need to drink some water bottles. So I'll drink some water bottles next time. Okay, now that we've done that, and don't worry, they're not asking for this. I'm gonna put not asking. This is not part of the question. This is the answer for this. If I wanted b by itself, I would take the inverse cosine, and I would go b equals inverse cosine of 3/5, and then make sure that your calculator is in degrees. Make sure calculator is in degree mode. Are we okay? All right, so here we go. In triangle ABC, the measure of angle C is 90. So I'm going to go draw my little triangle. And don't worry, guys, I'm slowing down. I'm slowing down in case you're like, I'm still writing. That's angle C. And it says that CB is 36. So I'm going to put A here. I'm going to put B here. So CB is 36. That's this length. I'm going to write 36. I'm going to put a right angle right there. BA is 85. So I'm going to write 85 right here. And AC is 77. So I'm going to put 77. 77. We're still okay? Okay. What is the value of tangent of angle A to the nearest hundredths? So I'm going to write SOHCAHTOA. And they don't say they want to know angle. They just want to know they want to know tan of A. So I'm going to exaggerate the A. So here it is. I'm going to go tan of angle A equals, and I'm going to underline the TOA. So tangent of angle A is opposite over adjacent. So here's my angle A. What is opposite?
36.
What is adjacent?
77.
So there it is. I'm going to write 36 over 77. Now, they said nearest hundredths, so they don't want it in fraction form. So let me go ahead and just put X's. They indicate numbers. I'm going to put a little dot. Number, number, number. So here's the decimal. That first digit after the decimal is called the... No, that's the tenth. No, you're good. You're good. There's a safe space. The next one after that is called the hundredth. And the next one after that is called the thousandths. Okay, good. Then we're good. So I'm going to take my calculator. I'm just going to go to Desmos. You will have a calculator on your Delta app. Don't worry, you'll be fine. So let me lower this and let me put Desmos here. So where's my Desmos? So here's my Desmos. Open graphing calculator. It could have been a scientific one, but here's my, I don't need the graph, so I'm just going to, all right, and I'm going to type in, what am I going to type in? 36 over 77. So I'm going to go 36 over 77. And there it is. So let me zoom in. So they said to the nearest what? 100. So it's going to be point what? No, that's the tenth. We need 0.47. Okay, well, actually, it depends. There's two vocabulary words. Let's see if Winters has used them. Have you ever heard the word truncated? No? Okay. Have you ever heard the word rounded? Okay. By default, we're going to do rounded. Did it say rounded or did it say, what is the value? Okay, so we're just going to assume rounded. We're going to assume rounded. If it's rounded, it's going to be 0.47. If you ever hear the word truncated, 0.47. Okay, so what was the word? Repeat the word that I just said. If you ever hear the word truncated, that just means as is, whatever it is. So if it was truncated, we would say 0.46 because it's whatever as is. Does that make sense, guys? What is that word? There it is. See if you can use it sometime. Maybe, okay. Do you guys still have winners? I know you guys, do you guys have, okay, when he's doing calculations, raise your hand and be like, should I truncate that or should I round it? And then let's see what Winter says. Oh, good question. I don't know. What does Winter say all the time? Permission to go on a tangent? Or did he say that? Or okay, yeah. So yeah, ask them the question like, should I round that or would you prefer that I truncate it? So yeah, ask them. And should I delete that part from my video or should I leave it? Look, Wince, you're in the video. Okay. Hey, Wince, you should give me a thumbs up on this video if you're watching it right now. All right, here we go. In triangle QRS, the measure of angle S is 90. The measure of angle Q 61 and QR 79 feet. Find the length of RS to the nearest foot. I love this. This is a very popular question on the ACT. I'm not sure how popular it is on the SAT, and it's possible that it could be TSI. So I'm going to put question mark on TSI. Let me know if you guys have seen this question on TSI. So here it is. I'm going to draw a right triangle. And the only one that's super important is this one. The right angle has to happen at what vertice? S. So label that S and put a little right triangle like that. Then it doesn't matter. The other two vertices, I just go down the alphabet. I'm going to call this one Q. I'm going to call this one R. Is everyone okay with how we did that triangle?
Yes.
Okay. Angle Q is how many degrees? So find angle Q. Put a little, I like to do that. And then I go 61 with a little degree symbol. So angle Q is 61 degrees. And then it says QR is 79. So that's this distance right here. 79. And I'm going to put feet. Find the length of RS. Okay, here's RS. I'm going to use angle Q. So I'm going to say this is little q. So there it is. Are we still okay?
Yes.
Okay. Check this out, guys. You guys are making so many gains today. I'm going to write SOHCAHTOA. So write SOHCAHTOA. Okay, ready? All right. With respect to the 61 degrees, that's the key. That's a key. You look at the 61 degrees and then you say this. Is that little q opposite, adjacent, or hypotenuse from the 61 degrees? Okay, what about that 79? Hypotenuse. Which one of these, the sine, cosine, or tangent, uses opposite and hypotenuse? Sine. So there it is. You're going to use sine. You're going to go sine, and you're going to put that number, 61 degrees, equals opposite little q over 79. And don't worry, we're gonna fix your logic right now for all times. You're gonna see. We're gonna do it right now. Are we okay?
Yeah.
Okay. You see this q over 79? That is division. Are we okay?
Yes.
I want to get rid of that 79. Chop, why do you want to get rid of it? Because I'm trying to solve for little q. So that means I need to get little q by itself. So what is the inverse operation of dividing? Multiplying. So if I want to get rid of the 79, what do I got to do to the right side? I got to what? Multiply. But look, there's an equal sign. So if you multiply the right side by 79, you got to do what to the left side? Multiply it as well. Is that making sense? Notice that we're using logic. So no longer, you're not going to be a robot anymore, miss. We're going to make sure that, sorry, am I too much in your face there? We're going to make sure that you know why you're doing what you're doing. So hopefully now you're feeling courageous and you're feeling your ACT score go up and TSI score and all those other scores. So now you're seeing you're not a robot. So remember, why are we doing what we're doing? We're trying to get Q by itself. So this is division. So I'm going to multiply by 79, but because there's an equal sign, whatever you do to one side, you got to do to the other. So there it is. Look, that's 79, and I put different colors to indicate because that's what I'm doing now. And look, all I'm doing is logic. I'm not giving you any steps or anything. I'm just using logic. So when you do that, here you go. I'm going back to my red. When you do that, you're going to have 79 sine 61 degrees is nothing more than little q. Oh, look, you got it. I got my little q by itself. Isn't that cool? I go to my Desmos or whatever system you're using. And I'm going to come in here and at first, and I know that I got to switch it, but don't worry, I'm going to pretend that I don't know. So I'm going to type in 79. And what was it? Was it sine? Functions. I'm going to push sine there. And then what did I have on the inside? I'm going to push 61. And then at first glance, I'm like, what the heck? And then I see that negative 76. And then I start thinking, can I have negative as a distance? Can I have negative as a distance? No, you can't have negative as a distance. So something's up. What did I not do? Well, this isn't, look what that is. That's a degree. I don't know if you guys have heard what radian is. Don't worry, we'll talk about radians. That's a degree. So I need to make sure that this is in what mode? Degree. So you click on the little wrench and then look in the very bottom. See how it says radians? That's what's highlighted right now. You hover over the degrees, you push it, and now look at that. 69.0949. So there it is. I'm going to put 69. That equals 69.0949. And then I go back and then it says nearest what? So I'm not going to say 69.0949. I'm just going to say 69. And I'll put units. What units? Feet. Do you feel like you're getting stronger? Okay. Don't worry, guys. We're almost done. We're almost done. All right. Find the length of side x in simplest radical form with rational denominator. Look, they threw a whole bunch of vocabulary at you. So simplest radical form, simplest radical, that means it has a square root. It doesn't have to be a square root. It could be a cubic root, fourth root. That's what you call a radicand. And it says simplest, so that means simplified. And then with a rational denominator, that means no radicals in denominator. That's what it means. Are we still okay? Okay. All right. So let me see. Do you remember when you were in geometry, and it's okay if you don't, we gave you a formula for a 45, 45, 90 triangle, and we wrote like n, and then we wrote n square root of 2. Those formulas come from somewhere. Yeah, put your pencils down, guys, because I want you guys to really take this in. I'll put this in red, and I'll write the other stuff in blue. So I want you guys to know that those formulas came from somewhere. If I were to call this n, and I were to call this n, and I were to call this n squared of 2, that's what that means. Then Pythagorean theorem says n squared plus n squared equals, and then I'm gonna say that I don't know this side, so what letter should I use? I'm gonna say that's m equals m squared. And then look, there's 2 of them here, so 2n squared equals m squared. And if I want to get m by itself, you're gonna go square root, and so m equals, then the square root of n squared is just n square root of 2. I know that I just went really fast. There was a lot of things that I should have covered. Don't write this down. I'm gonna give you time. Really fast. The definition of square root. So if you have x squared, the definition of x squared, that's just x. And then I guess square root of x times square root of x, that's just x as well. And I don't know, maybe you guys like happy faces. Square root of happy face times square root of happy face, that's just happy face. See? Maybe you guys like numbers, so square root of 9 times square root of 9, that's just 9. Well, the square root of 9, you guys know that's 3, I hope. And if you don't know that, that's fine. But I would like for you guys to know the square root of 9, that's 3 again. Look, 3 times 3, oh, look, that's 9 again. See how all the, I hope that's making a connection there with square roots and all that. Does that make sense? Okay, so that's where this formula comes from. See, n squared of 2 and n. So yeah, do you want to write any of that down or no? Okay, so I'll give you guys a 30-second head start. Go for it. Okay. All right, guys, here we go. You guys ready? So notice that I put a 1 here equals n squared of 2. So I'm going to put the number 1 right below that. So that means I can write n squared of 2 equals 1. What you want to figure out what one of these sides are. This is n, which in this case also equals x. That's what they want, find x. So I need to get n by itself. Don't worry, guys, we're almost done. I know this is difficult to do, especially ninth period. It's difficult, but we're almost there. So how do I get n by itself? Right now I have n times the square root of 2. Oh, what happened there? No, Copilot, go away. N times the square root of 2 equals 1. How do I get n by itself? Yeah, this is the product. N times the square root of 2. So how do I get n by itself?
Could you raise it to the power of 2 to get rid of the
I could, but if I were to raise to the power of 2, then I would have n squared. So right now I just have, I think I heard someone say it, but you said it softly. N times the square root of 2 equals 1. How would I isolate that n? Yeah, divide it. Divide it by what? Not 2, but the square root of 2. So here I go. I'm going to take my little blue color. I'm going to go divide by square root of 2, divide by square root of 2. So here's my answer. N equals 1 over square root of 2. And that says x equals n. So I can say x equals, because x and n are the same thing. See? Now here comes the problem. Don't worry, we're almost done. It says with a rational denominator. Look what it says. No radicals in the denominator. Do I have a radical in the denominator? I do. Is there a way that I can get rid of that square root of 2? Well, look, up here I wrote square root of happy face and square root of happy face. Just give me happy face. That happy face doesn't have a square root on it. Square root of x and square root of x is x. So I can get rid of that square root of 2 by multiplying by square root of 2. But here's the catch. Look, let's not be a robot. Here's the catch. I'm multiplying this. Don't write this down. Just listen right now. In a little bit, you can write it down. I'm multiplying this by square root of 2 over square root of 2. Why? Child, why are you doing what you're doing? Square root of 2 over square root of 2, that's just 1. Anytime I multiply by 1, have I changed the value of anything? No, because anytime you multiply by 1, it's itself. So look, no longer are you guys robots. Like, we're understanding now. And why did I choose square root of 2? Because the denominator was square root of 2. And to get rid of square root of 2, you got to multiply square root of 2 with itself to get rid of the square root. Is that making sense? So if I would have had 1 over square root of 5, I would have multiplied it by square root of 5 over square root of 5. If I would have had 1 over square root of 7, I would have multiplied it by square root of 7 over square root of 7, because that's just 1. And then I get rid of the square root in the bottom. Does that make sense to you guys? Okay, now you can write stuff down. And here's what you get now. You get square root of 2, because 1 times square root of 2 is square root of 2. And then square root of 2 times square root of 2, that's just 2. When you multiply fractions, you multiply the top with the top and the bottom with the bottom. Are we okay? Okay. Here's our answer. Okay, we're going to skip this question. Not that I don't think we can do it, but the immediate homework right now does not have any questions like this. So we're going to skip that question just for now. We will talk about it the next time for sure, 100%. Don't worry, we're almost done. We got 2 questions left, and that's it. So this one says, which segment is adjacent to angle N? Here's angle N. Yeah, this segment here, either MN or you want to call it little j or whatever. So segment MN. And I think that's what you're doing in Delta Math, or you might be able to call it little j as well. So this segment right here that I'm highlighting, that's adjacent. Does that make sense, guys? Okay. Find the value of sine k rounded to the nearest hundredth if necessary. Well, I need to figure out what little j is. I'm just going to do Pythagorean theorem. This is a special right triangle, but I'm just going to do Pythagorean theorem. No big deal. 10 squared plus 24 squared, that's my hypotenuse, the j, equals j squared. Be careful. Sometimes they don't give you the hypotenuse. Sometimes they give you a side, and you got to figure out, Okay. 10 squared is 100. 24, I don't know what 24 squared is. Do you guys know what 24 squared is? I'm going to go here. I'm going to put 24 squared. 576. 576 plus 100, 676. Oh, look, 676. That is 676 a thing? 676. Oh, it doesn't flow as good. Okay. All right. I'm going to take the square root of that. Square root. Let's see what the square root of 676 is. It's a perfect square root, guys. Oh, man. Let me clear it. Clear. Square root 676. There it is. 26. 26. Okay. Here we go. Here's angle K. It says they want to know sine K. So I'm going to write sine of K equals opposite. What's opposite? 24 over our hypotenuse. What's hypotenuse? 26. Now this reduces, but we don't care about simplest fraction. Nearest hundreds. So I'm going to take my calculator. Here's my calculator. And I'm going to go 24 over 26. So there it is. Nearest hundreds. What digit do I put? 0.92. Rounded and truncated are the same for this one. So I'm going to write 0.92. There it is. And now we're going to do this delta math. Don't worry, I'll give you the code right now. And then don't worry about the sectivity. We're not there yet.